Okay, so we'll take our quick look at the calendar. Today I will walk around in a little bit and check 1.10b. We're covering sections 2.1, 2.2, and 2.3. Has to do with absolute value and inequalities. Hopefully you've seen those things before. That homework is due on Friday. And just another reminder, I will not be here on Friday, but Peter will be here covering this class on Friday. He's great. He's not gonna check the homework. I'll check it when I come back. Monday is Columbus Day, so we don't have any day classes on Monday, and then we will see each other again on Wednesday, 1 week from today, just in time for our practice quiz for the first half of the period, and then our quiz for the second half of the period. Okay? Questions on the schedule? Okay, so let's come back here on page 121. A reminder that quiz is coming up soon. It's 1 week from today. You have the yellow QEF packet. I distributed that last class. You guys all have that? Lots of good practice problems in the QEF packet as you prepare for quiz number 2. And there are plenty of other resources listed here for you on page 121 to help you prepare for that quiz. And just a reminder, you can take the quiz or exam with any section of Math 095. And all the sections are listed here on this document. Up at the top, it tells you that our class meets at 9, but there's also a 10 or 11 on Wednesday. And if you flip to the back of this document, you'll find out when the Tuesday, Thursday folks are taking the quiz. It's a different quiz, but you're welcome to take it with any section that you want. But probably I will see you here next Wednesday at 9. And let's start with the objective here. Morgan. Okay, so number 1, discussion of the meaning and notation for absolute value. Okay, so have you guys seen the notation for absolute value? Do you know how to write absolute value? How do we write it?
Bars on either side of the number.
Bars on either side of the number. Okay, so if we had something like -5 and then bars on either side of the number. So we read this as the absolute value of -5.
What is that?
Oh, I don't know if there's probably a fancy word for those 2 lines. I don't know what the fancy word for the 2 lines is.
I remember.
Yeah, I don't know what the lines are called. Anybody know what the absolute value of -5 equals? It equals 5. Okay, we'll talk about that in a second. If we have 7, and then we put our absolute value lines around it, what's the absolute value of 7? 7. Okay, we've got everything we need up there in those 2 examples. Who can explain the rule that tells you what absolute value means?
Absolute value just basically says what's the numerical value of the number as opposed to like a negative sign.
Mm-hmm.
Or is it also true for exponents? Like the absolute value of 5 is 5.
Absolute value of 5 cubed, like there?
Oh, sorry, the square. Yeah.
This?
Yeah.
Yeah.
Isn't that 25?
It's 25.
Yeah.
Mm-hmm.
Isn't it the
Distance from 0. Can you explain a little bit more, Catherine?
So it was -5. I don't know the word to use, but it's 5 digits from 0. But yeah, number line. So it's 5 away from 0.
You guys buy that? If you're sitting at the number -5, how far are you from 0? You are 5 away. What if you're sitting at the number 7? How far are you? 1, 2, 3, 4, 5, 6, 7. How far are you from the origin, from 0? You're 7 away. Great. Absolute value represents distance from 0. What does that mean? What kind of a number is the answer to every absolute value problem? It's always positive because distance is always positive. You can be left of 0, you can be right of 0, but your distance is always a positive number. Super. Can you guys in your groups spend a minute working through parts A through F right here? Okay, so let's come back together here. First one, part A, absolute value of -6 is 6. Super. Next part, part B, negative absolute value of 6. So of course things get complicated as soon as we have extra negatives floating around, and part C is even worse. But the main idea here is that absolute value, I'll write this here, absolute value acts like parentheses in terms of our order of operations business, PEMDAS. So what that means is that you need to deal with whatever's in the absolute value first. It's like parentheses and it has the highest priority. So the first thing I need to handle in this one is not that negative sign in the front, that's secondary, but it's just the absolute value. What's the absolute value of 6? Is 6. So that yellow thing is 6. I'll highlight it. The two yellow things are equal. And then what's sitting in the front of the 6, according to the directions here, is a negative sign, right? It's that times -1 in the front. So the negative sign there, I'll write over it in blue. That negative just got copied over, okay? So you handle what's in the absolute value first, and then whatever's outside comes after. So same idea here. We're going to highlight this absolute value. What's the absolute value of -6? Is also 6. So the two greens are equal. And then what goes in the front? It's a negative sign. Okay, how about this? Is this an absolute value? It's not, it's just -6 in parentheses. So what's -6? It's just plain old 6, right? The opposite of 6. So that's just 6. Okay, then we get parts E and F. And if you wrote 10 for both of them, you got one right and one wrong. So one of these guys is equal to 10. Let's take a look at part F. Part F says, take the absolute value of -7. What is it? 7. And then plus absolute value of 3 is 3. And then add them, and we get 10. But a lot of people see that in part E, and part E is not that. Part E, again, absolute value is like parentheses. So you got to handle what's inside there first. So I'm going to swing out here, and I'm going to copy these parentheses, copy the absolute value, and then I'm going to handle what's inside. What's inside is this -7 plus 3. How much is -7 plus 3? Is -4. So that thing on the inside becomes -4 before the absolute value gets to act on it. Okay? And how much is the absolute value of -4? It's 4. So this one, the answer is 4. It is very tempting to think that absolute value just takes everything inside and makes it positive individually. That is not what absolute value does. Absolute value takes a single number and makes it positive. But there's no simple rule that says, oh, if you have this complicated thing inside, just make them all positive. Absolute value does not behave that way. Okay. Any questions on this absolute value business? All right, let's move to the next page, 122. So first of all, this symbol right here in between the X and the -3, anybody know what it's called? Is it less than or equal to or greater than or equal to? This is the greater than symbol. So this is greater than or equal to. And so I'll just copy the other things. X is greater than or equal to -3. That's what that says in English. Can anybody give me a value of X that works? Any value of X that's greater than or equal to -3? -3, just barely fits in there because it's equal to -3. So that one works. Any other number that works? 0 works. X equals 2 works. These are all numbers that are bigger than or equal to -3. Now I want something that doesn't work. -4. Let's see, X and X. How about a frowny face? This one does not work, okay? X equals -4 is not greater than or equal to -3, all right? How many numbers work in general? I have 3 numbers up there that work. Is that all of them? How many work? So how many numbers are there that are greater than or equal to -3?
Pretty much every positive.
Okay, so infinitely many right? Infinitely many numbers work. And in fact, we even missed some in between, like for example, x equals 1.372. Does that work? Right, so it doesn't have to be just these integers that we've listed here. There's infinitely many numbers that work. How many numbers don't work? Also infinitely many. There's plenty of numbers on both sides. In number 4, I'm going to ask you guys to graph. Each group is going to graph the solutions of one of these inequalities. It says on the whiteboard, scratch those directions. You guys are going to do it on your paper, and then one representative from each group is going to come up here on the smartboard and do that. So what I'd like you guys to do is work through each of these, but I'm going to assign one to each group. So you guys are part A. You by yourself is part B. C in the back corner. Yes, you guys are C. D here in the middle, and then E. So see if you can remember how to draw this stuff. Got these? All right, so part A. This says, is that a greater than symbol or a less than symbol? That's a less than symbol. X is less than 1. Have we shaded in the numbers here where X is less than 1? Chris says no. What don't you like about this one, Chris? All right, so the arrow has got all of them. It's okay to draw, you know, further than this thing, but as long as you have the arrow, then that's our way of saying all of them forever. Yeah, this is just x less than 1 and not x less than or equal to 1. So in some sense, there's like it doesn't quite get to 1, right? 1 is no good. Now I think that this group here tried to indicate that. You guys can see that Dwight didn't shade in the number 1, right? He went a little bit left of 1 and then put in a dot there. Is that okay? Is the number that Dwight put a dot on the last number that works? No. Yeah, like if you guys tried to put a dot on 0.9, then we could come in and say, hey, 0.99, you should have shaded that one too, because 0.99 is less than 1, and it works, and you didn't shade it. And no matter how close you try to shade to the number 1, there's no way to shade in the last number that works, because there is no last number that works. We could always play this game and say, hey, we can find something that you didn't shade in, but that it still works. So in order to fix that, we have this convention that says we're going to not include the number 1, but we're going to put an open circle on the number 1, which is our way of saying get all the way up to this number, but don't get to the number. And so this is how we mark it. Okay? So I've written down here in blue, if you see a less than symbol or a greater than symbol without the equals line below, you're using an open circle. That's what we just saw. Okay? If you see a less than or equal to, or a greater than or equal to, it's a filled in circle. See the difference? Okay, how about part B? Does this one look okay? X is greater than -2. Is that right? So there's one thing I'm going to ask. In fact, Chris, it was the one thing you observed about part A. What am I going to ask you to add on to this? Oh, you used my arrow. Oh, that's kind of efficient. I'd like you to use your own arrow. All right. Yeah, so draw an arrow. I'm going to be really picky because the arrow is the math way of saying it goes forever. All right? Okay, that looks good here. This one is kind of weird because the x is at the end. So technically this says 4 is greater than or equal to x. Is that right over there? Are those the numbers that satisfy 4 is greater than or equal to x? Let's see. Well, let's pick a number that's shaded in right now, like 5. Does 5 work if you plug in 5 here? 4 is greater than or equal to 5. Is that true? It's not true. So this isn't the right region that's shaded in. But it's really easy to get this kind of problem wrong because the x doesn't appear first. So in my mind, I always have to translate these problems. I need to have the x first so that I really know what I'm talking about. But if I want to put the x first, I'm really reading this from right to left. What symbol goes in between? It's the other one. I'm really reading it backwards, so the symbol changes direction because of my perspective. So this is really saying x is less than or equal to 4. That's all the values of x that are less than or equal to 4. Okay, so we're going to change the direction here, and we're going to shade in all the stuff to the left of 4. What else are we going to change about this one? It needs to be a solid dot. How come an open circle is not the right symbol? Yeah, open means not equal to 4, but equal to 4 is a possibility from the original. So we're going to fill that thing in. We're going to shift to the left, and I'm going to pick on this group for one last thing. I've got my other instruction up here. It says no floating. We want to draw something on the real number line, not floating above the real number line. And, you know, like I understand that in past math classes, maybe teacher said draw it up above so we can see it. There's other ways for us to see it. The real number line exists and it's there. And the way you make me see it is really shade in and use some graphite, all right? Make sure that I can really see it. And that way we don't have to draw something up above, okay? Okay. You guys want to change yours?
Yeah.
All right.
When we went a little flipping thing.
Yeah, so if we flip this guy, what should it say in between when we flip it? X is greater than. So this is just going the wrong way. But it's so easy to make that mistake, right? So I'm glad that we see that mistake here so that we don't make it. I can't handle it when the X is on the right. So I just change it to the left. So let's see, is it a filled in circle or an open circle? Open is good. And this one is going to the right. So we'll shade it in and then we'll put an arrow going that way. Okay, how about part E? X is greater than or equal to 3. How does that one look? Is that right? Yeah, looks good. So all the numbers bigger than or equal to 3, that's fine. And then down here at part F, 3 is less than or equal to X. So nobody had this one, but again, I would write this the other way. X there, 3 there. What goes in between? Is greater than or equal to. Okay, so we start at the number 3. Start at the number 3. Filled in or empty? Filled in. And which way are we going? To the right. Shaded forever. And what do we notice? It's the same as the one above it. So of course it is, because when we rewrote it, we got exactly what part E said, but you know, they look different initially. Okay, any questions on the inequality business? Okay, moving right along. Next page. All right, so here's a puzzle you guys are going to complete in your groups. What you're going to do is fill in each of these empty boxes with either a positive sign or a negative sign. You got to make it so that all the fractions that have equal signs in between are equal. So in the top row, you're going to make 3 fractions that are equal. In the bottom row, you're going to make 3 fractions that are equal. But no 2 of the 6 fractions should look exactly the same. And I'll give you one hint just to get everybody started here. What we're going to do is fill in the box in the middle. I'm going to fill that in with a minus sign. And then I'm going to fill in the box in the middle on the bottom row. What does it have to be if no 2 of the fractions look the same? This one has to be positive because it has to look different than the one we just did. So now I want you to branch off from the ones in the middle. On the left, you got to fill in the boxes so that you still have a fraction that's really the same as -1/2. And on the right, the same thing, but they all have to look different from each other. So work with your groups, see if you can fill in those 8 different symbols. How do we make a fraction negative? What kind of signs do we use to make a negative fraction? So we could use a positive and a negative. We know when we divide here, we'll get negative. What's the other way to get negative? Negative and a positive, right? How do you make a fraction positive? So 2 negatives, we know when you divide, you get a positive. What's the other way to make it positive? There's 2 positives. Good. Related to that is this last part, which says which of these are equal to each other. So which of these guys are equal to each other? So I'm just going to start highlighting. Positive 1/2 is the next thing. Is part B the same as positive 1/2? No. How about part C? Yes, we know that that's also positive half. How about D? No. What about E? Also no. Okay, so now let's look at that one. -1/2 is the same as which one? the same as d, 1 over -2, which is the same as -1/2. So the point of all this is that if you have a fraction where there's a negative sign on the top or a negative sign on the bottom, you are perfectly within your rights to put that negative sign in the front, if that helps you. So a single negative sign anywhere can be moved anywhere, okay? That's the point of these guys. Okay, so the classwork starts here. I think, oh, I don't know. There might be time to finish the classwork and then go back and start doing some of the stuff from last class if you didn't have a chance to finish all the classwork from last time. But let's see if we can get through the classwork first. I'll come around and check homework.